This is lesson 4-5, domain and range of a function. So here we have some review vocabulary for things that we've talked about throughout the unit. We know that the set from any independent variables is called the domain, and it is typically our x values when we are dealing with functions. The set from the dependent variable is called the range. That's our y values or f of x values. And something is a function if the relation is based on a clearly defined rule. And the most important thing to remember is for a relation to be a function, every input or domain value must have one and only one range value for it to be sufficient. And again, more simply put, all domain values in a function can only occur once. So if you have a list of the domain values, if you see that they occur more than once, it is not going to be a function. So when we're finding the range of a function based on a given domain, we want to take the domain and plug the values into the function rule. From there, we'll write all of our values of the range with our set notation, the curly braces. Here's an example. F of x is equal to 2x minus 3, and they give us a domain of -2, 0, 1, and 5. So I'm going to take each domain value and plug it in. So f of -2 is equal to 2 times -2 minus 3, which is equal to -7. Next one, f of 0, would be equal to 2 times 0 minus 3, which is -3. F of 1 would be equal to 2 times 1 minus 3, which would be -1. And finally, f of 5 would be equal to 2 times 5 minus 3, which is equal to 7. So our range for this function is simply going to be -7, -3, -1, and 7. Here's another example for you to consider. Please make sure you're sketching the graph when you're doing the example in your notes. And also please make sure that you are writing down every single portion of this example and then pausing the video to try it on your own. Let's take a look at the answers. Let's first evaluate f of -3, f of -1, and f of 2. Since we are given a graph here, we want to take a look directly at the graph. Again, we should be labeling the graph as much as we possibly can. F of -3 in this case would be right here, and that's equal to 1. F of -1 is going to be right down here, and that's going to be equal to -3. F of 2 is going to be right there, and that's going to be equal to 0. Next, can the function rule give you a range value for when x equals 5? Why or why not? So x equals 5 is out here. The function is clearly stopped at this point right here. So the answer is no. The function does not go through x equals 5. Therefore, is x equals 5 in the domain? The answer is no, since the graph does not go through at x equals 5. Let's write our domain and range as a single inequality and in interval notation. So let's start with the domain. As a single inequality means that since we stop at places here, we're going to have a compound inequality. So this goes as far out as -5, and it goes as far up to x equals 3. That's my domain. So -5 is less than or equal to x, which is less than or equal to 3. I want to include those both because they are included in the function. For the interval notation, I'm going to include -5, and my max bound, my high bound, is going to be at 3, and that is also included. Let's do the range. As a single inequality, now range, we're looking at y values. The lowest I go is down here at -4. The highest I go is up here at 5. So the range is going to start out at -4, which is less than or equal to x, which is less than or equal to 5. And then for our interval notation, we staple bracket 4 and we staple bracket 5. Let's talk about a reasonable domain and range. And that's typically found by reading your problem, interpreting the problem, and then using common sense. Here's an example. A gardener wants to plant a new square garden. Now we're talking about a garden, and we're talking about really a geometric shape when we talk about a square. We have a function a of x equals x squared that represents the area a of x in square feet based on the length of the space x feet. The maximum area is 64 square feet. Now, the area is clearly the range, and the length of the space, x feet, is going to be your domain. In this case, because we're speaking of area, there is absolutely no reason to be using negative numbers or 0, because then the garden wouldn't exist. Anything above 0, in this case, would be fair game, up to and including where we would get a maximum area of 64 square feet. So because the maximum area is square feet, we have to find x values that produce an area of 64 square feet or less. We should test values of x to find a maximum. In this case, testing it out, 8 would be the highest x value I can use because 8 squared is 64. So my domain in this case is going to be 0 not included, because anything above 0 will work, up to and including 8, because that would fit the maximum square footage for area. In so doing the range, we plug in the low bound and the high bound, and we keep the same notation. So plugging in the low bound, 0 squared would be 0. So that's our low bound and not included. The high bound would be 8 squared, which is 64, and that would be included. So my range is therefore then equal to 0 not included up to and including 64. Here's an example for you to try. Given the situation below, determine a reasonable domain and range. A charter boat travels a maximum rate of 25 miles per hour. The function d of x equals 25x represents the distance d of x in miles that the boat can travel in x hours. So x hours, x is going to be my domain, and d of x, the miles, is going to be my range. Notice that the charter boat can travel a maximum distance of 75 miles from the shore. Pause the video at this point to give yourself a chance to try and find your reasonable domain and range. Here are your answers. Since we can only travel a maximum distance of 75 miles from the shore, that means we can only travel a maximum of 3 hours. Traveling 0 hours makes no sense whatsoever, so my domain will be 0 not included up to and including 3 hours. The range will be coming from the domain. I plug in my low and high bounds, and I get a range of 0 not included to 75 miles included. If you're having any issues in any portion of this lesson, please make sure you are emailing me or consulting me in class.